Becoming a better software developer. In this course, I'll discuss about who a developer is, what the responsibilities of a developer are, the kind of challenges that developers face today, and also I'll do a deep dive into how to become a better software developer. So what are the courses that one can do and how can they become a great software developer? In this session, I'll discuss about a software developer and the responsibilities of a software developer. A software developer is an engineer who essentially writes code. That's the main responsibility. So the first responsibility of a software engineer is to understand customers' needs. Customers come in all types. There are different kinds of customers. Each customer has a different need. They come from different cultures. They work in different industries. So the customer might be of different age groups, could be of a different gender. They will have different needs. They come from a different country, their needs will be different. They come from a different state, their needs might vary, and depending on the kind of work that they do, their needs might be different. So each customer has got a variety of needs depending on their own circumstances. So it's really important to understand customers' needs to create a solution that addresses that particular needs. So the first and foremost responsibility of any developer would be to understand their customers in the best possible way. This can be done by conducting research as well as interviewing specific customers from different areas and asking the right set of questions, doing some surveys, talking to them in person, empathizing with the users, understanding their pain points, trying to figure out what really do they need. So am I offering exactly what they are in need of, or am I offering something else? So does my feature add value to the customer? So in order to be a great developer, the first responsibility, always understand the customer's needs. The second responsibility that a developer has on a daily basis is project management, task management, and communication. So the first part is to manage the project. So in order to manage a project, you'll have to first understand the customer needs and then try to estimate the solution and the components of the solution. So you perform something called scoping. That's where you try to estimate how much time will this particular feature or component to develop this feature takes. So in addition to that, sometimes you might have to estimate some tasks such as fixing bugs, writing test cases. So it could be anything. So you're essentially trying to estimate the amount of man hours or man days required for completing a project or task at hand. And then there will be some kind of planning involved. So you'll have to decide whether you are gonna use an agile methodology or a scrum methodology, or what kinds of techniques and tools you would like to use, and how do you want to complete this project, what technologies are needed, which programming language to use as backend and which one to use for front end, what database should I use. So there is a lot of planning involved, and that planning is done by discussing with other developers and other engineers in the team. Once the planning is complete, you have to manage your task. So there is a lot of time management that you need to do across these various aspects of project management. So a bit of project management. Normally there is a scrum master or a project manager who will take care of this, but the developers are also responsible to do some of the projects for which they claim ownership, and it's their responsibility to report the status of their project with the project management and the rest of the team. So overall, in this process of day-to-day job, there is a lot of communication involved. So for communication you need a lot of soft skills, which in turn are determined by the way in which you are able to articulate something to the rest of the team. You should be able to articulate anything in a very concise and clear manner so the other person would understand it very easily. So this plays a very crucial role in the daily job of a developer. And in communication you might also want to talk about why this project took more time or less time, why this project needs more estimates, and then you'll also have to communicate with the rest of the team any challenges that you faced and you're likely to face, and help other team members as well. And in the process of a developer's day job, developer would be involved in creating a large number of artifacts. So some artifacts come under design and architecture. So the developer, once the requirements are clear, will come up with a design document. It could be a high level design document or a low level design document, and some diagrams. Could be UML diagrams or could be architectural diagrams, and how each component interacts with other components, what are the components involved, how their interactions are. It could be use case scenarios, or it could be flow from one component to other, what data is exchanged between components, and what data is stored in the database, how and when the database is accessed, and things like that. And they're also involved in writing a lot of product documentation, like how this feature works, what features are available in this product, what are the use case scenarios, and what can you do, what settings you can make, how to modify the look and feel. And it could be anything related to the how to use the product in simple terms. It could be in plain English, it could be a PDF, it could be a web document, it could be a Word document, and that documentation is provided to the end user in order for the end user to use the product in an efficient way to solve the problems that they are facing. And the main aspect of a developer is coding. So either the developer is prototyping new features or fixing existing bugs or newly found bugs. In prototyping new features, the developer is kind of writing code for features that will improve the existing product, and then the features will be released as a new release or a new version of the product. And fixing bugs, there will be internal testing teams that will run tests, and there could be automated test suites that are being run every day. And any internal bugs found during testing would have to be resolved by the developer. In addition, if customers are reporting some kind of bugs, then there will be a level 3 support and level 2 support. The level 2 support person will be talking to the customer and creating bugs, and the level 3 and developers would work on resolving those bugs, which would indicate they will try to reproduce the same scenario as the customer's production environment. And once they reproduce, they will be able to find the bug, the root cause, and fix it. And the other major responsibility is collaborating with peers. So there is a concept called rapid prototyping and peer programming. In this concept, two people will be working on the same project. They will be sitting side by side and they start to work on the same code base. One person will be writing the code, the other person will be reviewing the code on the fly, and both will be working and complementing each other's work and also finding any problems on the fly. And that would indicate that they are trying to solve the problems straight. Even before the problem becomes big, you are getting a straight review from the other person, and they will exchange roles. One person codes, next time the other person codes, and this person will be reviewing it. so they can discuss and they will do a lot of things. And this is a really interesting way to program, because the focus is always there. You are not distracted. You will continue to work on the project without any distractions, and any obstacles will be solved on the fly. And then there is a concept of peer review. This is really important. We need to review each other's work. So peer review could be document review, design review, architecture review, or code review. As shown in this example diagram, so the reviewer might be providing some additional comments, might agree, might approve or reject, might ask for changes, might provide an alternative solution. Normally the peer who's reviewing might be a subject matter expert in the code area in which you have made changes, and the peer would be providing some useful feedback which you can integrate into your work. And there might be different rounds of peer reviews. So once the peer has reviewed the code, the comments will be sent back to you, and then you'll have to work on those comments and justify why you did it this way, and then you will make some improvements in your code, and then it will go back to the peer for review. And once the peer is happy, the review is complete, the peer will approve the code, and the code becomes part of the product. So peer review and iterative feedback really helps the developer in ensuring the quality of the code. And the other responsibility of the developer is to ensure software quality. So quality can be ensured by testing in different ways the product and the use cases. The first kind of testing is unit testing, where every specific element of your feature or the code that you have written. So for example, you will write a test for each function that you have developed. So unit testing is very, very low level testing. You are testing every function with different arguments. You pass corner case arguments to the function and try to test it. And it will try to find bugs within a small chunk of code that you have written. But then comes the integration testing. So how does your component work with all the other components in the product? So integration tests are product level tests which will involve more than one component, and then they will be run on the product and try to find if there are any integration related problems. And once they are found, the developer has to fix them as well. And then there are a different set of tests called performance or stress tests. So the performance tests are mainly for measuring the performance of a product in a under given constraints. So for example, if the test will be using 10 threads to perform an operation, so it might have another test with 100 threads to perform that operation and see if there is any contention involved. Will the performance degrade with additional load? How does the system perform? Does it succumb to the load? Will it die? Will it crash? Will it scale up? Will it scale down? Is it elastic in nature? Is it flexible? So that's what you're testing there. And stress tests are like you're performing kind of stress, you're load testing, you're reducing the available resources, and you're trying to run some tests and see how the system reacts. So these are important and will be run at the end of just before your product release to check the performance compared to the benchmark performance from the previous release. And it's okay to have the same performance, but you have to ensure that it doesn't degrade further. And it's always good if performance improves with the newer release. And the fourth, least but not the last, security guidelines. So things like vulnerabilities, memory leaks, buffer overrun. You need to take care that every memory that's being allocated is getting deallocated, and you are not double deleting some memory that's been allocated. So the normal way is to run certain tools like Valgrind. You could run Valgrind, which will find memory leaks, or if multiple threads are trying to do reads and writes, it will try to identify that. so you can find any bugs related to security or vulnerabilities. It's really important that it has been taken care of so that hackers cannot exploit vulnerabilities in your product.